51, the directions say, factor the expression and use the fundamental identities to simplify. Use a graph utility to check your result graphically. Now, what this is talking about is it wants you to first factor. If it's saying to factor, it's talking about a GCF, two binomials, and lastly, the sum of cubes or the difference of cubes formula. Okay? Now, I'm going to be talking about the page from yesterday that we talked about on Friday, I should say, regarding all the identities. Sine squared of theta plus the cosine squared of theta is equal to 1. Tangent squared of theta, 1 plus tangent squared theta is equal to secant squared theta. And then 1 plus the cotangent squared theta is equal to the cosecant squared theta. Now those three identities, with every one of them you actually have 3 that you consistently use and 5 total from each one of them that you can have. Meaning, I can solve for sine squared there, I can solve for cosine squared. I can solve for sine, or I could solve for cosine and have the square root visible then, to be able to understand that. So we actually have 5 in every one of those. But with that said, generally you're only going to use the first 3. Do we get that, yay or nay? Okay. So, with that said, number 51, it says to factor first. So when I factor, the first thing you need to look for is, do I have a GCF? What's your phone? Do I have a GCF? I do, and what is it? No. It is the cotangent squared of x. So if I pull out a cotangent squared, the operation that I'm actually doing there is multiplication, yes? So if I pull that out, the opposite of multiplication is division, so what's cotangent squared divided by cotangent squared? 1. And what is cotangent squared of x times cosine squared of x divided by cotangent squared? Cosine squared of x. Now, we factored it. I have pulled out a cotangent squared. I literally divided each term by cotangent squared, which is why I get 1 minus cosine squared in there. Now my question to you is, what out of those trig functions should I be using out of those identities? Now I'm going to keep them on the board again so that you can see them over here, since I'm going to be going back and forth. Now, which one deals with cosine squared? The first one. So if I'm dealing with this first one right here, what am I going to do here? I'm going to solve, and I'm going to take over that cosine squared. So what is 1 minus cosine squared actually equal to? Sine squared of x. So the cotangent squared of x, this whole thing becomes sine squared of theta. Or x, sorry. Did we get that? Now, I'm not done, because what is cotangent squared in terms of sine and cosine? Cosine squared of x over the sine squared of x, and then I'm multiplying it by the sine squared of x. And what happens with your sine squared of x? Those cancel out, and I am left with cosine squared of x. Factor the expression and use the fundamental identities to simplify. Use a graph utility to graph your result graphically. Still the same concept. Do I have a GCF here? There's not a tangent squared in every single term because it's a 1 at the end. Do we understand that? In order to have a GCF, it has to be in every single term. So since I don't have a GCF, the next thing I need to do is what? Try to put it into two binomials. So I'm going to put this into two binomials, and I'm going to ask you, how can I break up tangent to the 4th of x? Tangent squared of x, tangent squared of x. And I need to have a positive 1. So how do I get a positive outcome? Plus plus or minus minus. How do I know which one to use? Look at the middle term and I need plus plus. I need factors of 1. 1 and 1. Now, with that said, can you tell me which identity you would use? The middle one, which is the second one, 1 plus the tangent squared of x is equal to secant squared of x, right? So these two terms become secant squared of x. These two terms become secant squared of x. And they're attached by multiplication. So what is secant squared times secant squared? Secant to the 4th of x. Done. You're going to look to see what is the most of it. And this tangent squared. So the only one that has tangent squared is going to be the middle one. How do I use them? You're looking for substitutions. What I want you to think about today is think of a basketball team, okay, or a football team, any sporting event that you're at, okay? When you're on a baseball team, there's many different, if a shortstop goes out, somebody else has to replace that shortstop. That doesn't mean you're going to sub in somebody that needs the shortstop. You're going to pull them from someplace else within the field, right? So you might move a certain person around that has several different talents, right? That's exactly the same concept here. I have a 1, a tangent squared, and a secant squared all within on my playing field. But I can move them around for different scenarios. Does that make sense? I can move this tangent squared over here by subtracting tangent squared from both sides to have 1 is equal to secant squared minus tangent squared. I may need to use that at some point. How do I know which one I need? I look at the problem and I see what's in there. In this case, tangent squared and 1 was in there, attached by addition, which means I'm keeping them on the same side. And every place I see 1 plus the tangent squared, I can plug that in as the secant squared. Does that make sense? So it's a matter of finding the perfect fit for that problem. And each one is going to be different. Do we understand 55? 58, this is a homework problem. So we're still factoring if we can. So if I'm factoring this, do I have a GCF? In other words, is there something in common with each of them? The x is part of it. Like you can't have a trig function without having beta or x. Do you get what I'm saying? It has to stay there. The 4th is part of the secant. That says that I have 4 secants there. Okay? So what this tells you is that there's not a GCF, which you're going to have to immediately try to put this into what? 2 binomials. So this goes into 2 binomials. And can I break down secant to the 4th evenly? Secant squared and secant squared. How about a negative? I need to have a negative, so what do I need to do? I need to have opposite signs. And how do I break down tangent to the 4th evenly? Tangent squared and tangent squared. Okay, now which identity would you use up here? You'd still use the second one, and what's an easy thing to do at this point? You're overthinking the situation. I have a really easy plug and chug here, because every time I see secant squared, what can I plug in for it? 1 plus tangent squared. It doesn't matter which direction you go with it, it's just a matter of being consistent in what you do. Does that make sense? So every place that I see a secant squared, what am I going to put in place of it? So this is actually going to become 1 plus the tangent squared of x plus the tangent squared of x. And secant squared is going to be 1 plus the tangent squared of x minus the tangent squared of x. Do you see what I plugged in for secant squared? Now simplify each parenthesis. How many tangent squareds do I have over here? So I'm going to have 1 plus 2 times the tangent squared of x. And then what happens to my tangents over here? Those cancel out, and I'm left with a 1. So if I multiply that by 1, does anything change to it? No. So I have 1 plus 2 times the tangent squared of x. And I'm done.
What are we succeeding by doing this?
What you're trying to do is you're trying to put it in the absolute smallest possible terms that you can.
Why?
Instead of having 2 trig functions, you want to try to put it down to 1 small trig function.
I we could just make the answer easier if what's up there.
No.
It's just so it's really confusing.
Well, it's the same thing if I take out all the trig functions and just put in the x's. It's exactly the same procedure. X to the 4th times y, or minus y to the 4th. It goes right back to algebra 2. It goes right back to algebra 2. But now we're just throwing trig functions in with it.
I'll give you guys my 2 because we're
These are attached by multiplication. These are attached by addition. Does that make sense? So I have 1 tangent squared and I have another tangent squared. So how many tangent squares do I have total? 2. Does that make sense? Okay. 62! Yes, Dixie.
On that last one, why couldn't you just make the second one 1? Does that be like bringing the tangent over and it'd be in the square?
Same thing.
All right.
It's exactly the same thing. You wouldn't be wrong in doing that. Your brain sees it differently. You're absolutely so correct.
question. For 51, you took out the tangent of 2 of x, but not every single, you can't pull that out every single one.
I can't because this is a term and this is a term. So you're looking at it per terms. Okay? So in the first term, I have a cotangent squared. In the second term, I also have a cotangent squared. Does that make sense? Okay, 62. This is a homework problem. And in 62, it says, perform the multiplication and use the fundamental identities to simplify. Perform the multiplication and use the fundamental identities to simplify. Now, what do we do? It says to perform the multiplication, which means you got a FOIL here. So cotangent of x times cotangent of x is cotangent squared x. Now, what do you notice about these two things? They are conjugates. Do you remember the term conjugate? Conjugate means they're exactly the same parentheses, but the middle term would be opposite. Do you understand that? So when you're multiplying conjugates, the outer and inner always cancel out, which means you only have to multiply the first terms together and the last terms together. Do you understand that? Now, this is going to be minus the cosecant squared of x. Again, the reason why we do this is because those are conjugates of one another, and inner and outer will always cancel. Okay, so now, what's the dead giveaway here?
Cosecant squared x.
Every place I see a cosecant squared, what can I replace it with? 1 plus cotangent. Or Stacy, what could you do here? You saw it last example. Not 1. Cotangent squared of x minus the quantity 1 plus the cotangent squared of x. Now, every place I see cosecant, I have 1 term that I'm now replacing with 2 terms. Do we understand that? Which is why I need to have a parentheses around it, because I'm not just subtracting 1 term off like I was before, I'm subtracting off 2 terms. Do we understand that, yay or nay? Okay, so what do? I distribute. And what happens to my cotangent squares? These cancel out, and I am left with negative 1. Do you understand this? Okay, Okay, 67. It says perform the addition or subtraction, use the fundamental identities to simplify. So what do we have to do in this case?
The tangent over tangent.
I need to get a common denominator. So before I can do that, I have to put tangent of x over 1, because those are two separate terms there. Do you see that? So what is my least common denominator between 1 and tangent of x? Simply tangent of x. So I need each one of these denominators to turn into tangent of x. Do we see that? So what did I multiply 1 by to get tangent of x? Tangent, so tan times tan is tangent squared. We all see that. Now, I'm going to change this to negative secant squared there, because it was subtraction. That way I'm not messing that up, and I know that I have to distribute the negative to every single thing. Now, what did I multiply tangent by? Did I do anything to it? No. So I'm just going to make that negative secant squared of x. Now, what do I do? Do I have the same denominator? So what do? I marry them. So this is going to be tangent of squared x minus secant squared x all over tangent of x. Now, which trig identity would you use? The second one. Now, let's think about this a minute. I need tangent to be positive and secant to be negative, which means I need them all on the same side. So if I bring that secant squared over, that makes it negative. Now, what do I have to do with that one? Subtract it. So what does tangent squared minus secant squared equal? Do we all understand that that's negative 1? This whole thing becomes negative 1. Have I lost anybody there? Have I lost anybody there? If I have, stop me so I can back it up and make sure that you're understanding. Okay, what I did is I used 1 plus the tangent squared of x is equal to the secant squared of x. I brought the secant squared over on the same side as tangent. And the way I did that is I subtracted it. Make sense? Now I have to get rid of the 1. So how do I get rid of the 1? Subtract it. So tangent squared of x minus the secant squared of x is equal to negative 1.
So you just did match that.
I did it to match what I had in the problem. One of those substitutions that I had to manipulate it to get what I needed on my paper. Do we all understand that? So every time I see tangent squared of x minus secant squared of x, that whole thing will be equal to the value negative 1. Now, I don't like this. Can I rewrite this? This is going to be negative 1 times 1 over the tangent of x. What is 1 over tangent of x? Cotangent. So what I actually have is negative cotangent of x. Do we all see that? 1 over tangent is cotangent. I know. Isn't it ridiculous? But it's fun.
No.
I love this part here. This is like heavenly.
I leave it as negative 1 over tangent of x.
It will not be completely finished. Because you guys tell me, would you rather see 2 or 1/2? You'd rather see 2, which means you'd rather see a whole number with a trig function rather than a fractional trig function. You know I'm right, you just don't want to admit it because you'd rather stop at 1 over tangent.
I'd rather multiply by 1 over 2 than divide by 2.
I hear ya. 66, it's a homework problem. Okay, I do want to take the time to make sure that you're understanding something. Everyone look at me and listen for a minute, please. This stuff in this chapter is very difficult. It's one of those things that you have to have a strong Algebra 2 background for, because it's going to be adding, subtracting, multiplying, dividing, trig functions, and trig expressions. And it's going to be simplifying them down to the smallest, neatest little package that you possibly can, and putting a nice bow on it. Which means for many of us, we're going to have a really big eraser. Because you're going to make a lot of mistakes. Now, here's my best best recommendation that I can give you. Are we listening? Go to Walmart. Get yourself a 16 by 20 dry erase mark board. If you haven't gotten one, or if you have one at your house already that you can use, get it out. Go get yourself a pack of dry erase markers. And what do I suggest you do? Do all of your problems on that dry erase marker, on that board. After you get that completely done and you understand it, okay? After you get it completely done and you understand it, then what you need to do is copy that to a sheet of paper. It's going to help you, and you're not going to have near the amount of erasing. Does that make sense? Okay? Now, I do have some dry erase marker boards up there. I can't give you, I know, I have one less right now. I cannot give you the markers, but if you would like to borrow the dry erase board, you may borrow a dry erase board. Now, understand something. That's not very big. Most girls, whenever we're dealing with trade functions, are not going to be able to write small enough on there.
Most guys, they might be able to get 4 or 5 problems on that.
Some guys might be able to put 2 problems on there. That's probably right. Okay? So if you want to borrow one, I will allow you to borrow one. I'm going to tell you straight up, I cannot give you markers. You guys can use the board stuff. Do y'all understand why I'm telling you to get a big board? It's going to help you not waste the paper. It's going to help. What is that? It's going to help you. And I want you to make sure I assign the evens. Why?
They can check around to eat.
Because the odds are in the back of the book and they're step by step for a lot of them. They do in this because it's a proof. Which is why I gave you the evens. Okay? Do we all understand that, yes or no? Okay, so 66. I need to get a common denominator there, so what do I do?
Multiply by each other.
I need to multiply them by both of them. So it's going to be secant of x plus 1 times secant of x minus 1. Don't get ahead of yourself yet.
I'm already done.
Well, that's good. Okay, now, do we understand that that's our LCD? When in doubt, when they're different, what do? It's no different than taking 1/2 plus 1/3. You multiply the 2 and the 3 together, right? So I need each one of these denominators to be secant of x plus 1 times secant of x minus 1. Okay, so now, what did I multiply secant of x plus 1 to get that new denominator? I bring down the 1, and then I multiply by secant of x minus 1. Why did I have to bring down the 1? In this case, is the 1 going to matter? No, the 1's not going to matter, but what if it was a 2? Would it matter then? Yes, so get in the habit of continually bringing it down. The next one, what did I multiply secant of x minus 1 to get that new denominator? I'm going to multiply this by negative 1 times the secant of x plus 1. Now, does that negative 1 matter? Yes, it does matter. Okay, so with that said, you have to keep it. So now that I have the same denominator, what do I need to do? Marry them, so this is going to be the secant of x minus 1 minus the secant of x minus 1 all over my denominator. Now what do I do?
Why do you make it negative?
Oh, because it was already a negative 1 at the beginning. That's the problem.
I don't know.
In the problem, it was minus, so I immediately changed my subtraction to addition. So I do not forget whenever I'm distributing that negative that it goes not just with one term, but every term. Katrina?
Why would you put it?
Because I just didn't write it correctly. Thank you. I thought I wrote minus the first time. Okay. Now, what I do on the top is simplify. My secants cancel out, I'm left with negative 2. And on the bottom, what do you think you're going to do on the bottom? FOIL that. And that's going to give you conjugates. So I multiply the first together and the last to give me secant squared minus 1. Does that look familiar? it looks like if you solve that second identity for tangent squared, you're going to get secant squared minus 1. So what we have here is negative 2 all over tangent squared of x. Do I like that? Why do I not like that? You like that because you don't mind the fraction at this point. But if I give you a problem of just adding and subtracting fractions the whole time, you'd hate me.
Bring it on.
So this is negative 2 times 1 over the tangent squared of x, which gives me negative 2 times the cotangent squared of x. Over this stuff? Not for a while.
Whatever, this is the contact.
Okay, so the rest of the period is yours. I want you guys to work on this. You guys have, a good 10 minutes here. I do not want you to talk. I want you to figure out how to do this. Take your time. Do not clean up before 11:32.
We'll go with 11:31.
11:31 and a half.
No, we'll go around, just ballpark.
Okay?